Naming acids is the last type of naming that we are going to cover. The definition of an acid is a molecular compound that releases hydrogen ions when dissolved in water. The way that you will recognize an acid is that acids always start with hydrogen. So any chemical formula that starts with hydrogen is classified as an acid. There are two types of acids. The first is a binary acid. So the prefix bi means two. So that's made of only two elements. And so it's always going to be hydrogen plus some anion, some nonmetal. Actually, let's change that to nonmetal. So the pattern for that is that you're always going to start with the prefix hydro. You're going to use the nonmetal base name, change the ending of that to ic, and then write the word acid at the end of the name. All acids names end with the word acid. Dang it. So the pattern is hydro blank ic acid, and then you just fill in that blank with whatever your nonmetal is. So if we were naming HCl, hydro blank ic acid, and you fill in that blank with your anion, which is chlorine. So this becomes hydrochloric acid. HCN, hydro blank ic acid. CN is cyanide. So fill in that blank with that cyanic acid. So hydrocyanic acid. And then H2S. S is sulfur. So that becomes hydrosulfuric acid. When you're putting the formulas of these together from the name, just remember that all acids start with hydrogen, so that's going to be your cation, and then the name will tell you what the anion is. So hydrobromic acid, bromic tells me my anion is bromine, which is a -1 charge. And then just like with ionic compounds, you are going to balance out these charges. So hydrogen's a +1, bromine's a -1. They already balance out, so you just need one of each. HBr would be your formula for that. Hydrofluoric acid. So hydrogen, always because it's an acid, and then fluoric tells me my anion is fluorine. So it's just HF. The second type of acid is called an oxyacid. Oxyacids contain oxygen. And that oxygen is part of a polyatomic ion, always. So the name of the polyatomic ion tells you how to name the acid. If you have the oxyanion, so the anion containing oxygen that ends with 8, you change it to ic acid. If the anion ends with ite, you change it to us acid. So 8 equals ic, ite equals us. So when we are naming these, this is acetate. Oh, and that should be C2, sorry. So that's acetate. So it becomes acetic acid. 8 ic. NO2 is nitrite. Ite is us. So this is nitrous acid. Notice with these oxyacids, you are not starting with hydro. You only start with hydro if there's no oxygen in the formula. H3PO4, PO4 is phosphate. So again, 8 is ic. This is phosphoric acid. Putting the formulas together, you just go backwards for pretty much from what we just did. So nitrous acid, us, tells me that it was ite, nitrite, which is NO2 with a -1 charge. And then all acids, of course, have hydrogen. So hydrogen +1, NO2 -1, so they already balance out. So it's just HNO2. Sulfuric acid, that ic tells me my polyatomic ion is 8. So I have hydrogen with sulfate, which is SO4 with a -2 charge. So I need 2 hydrogens to cancel out the charge of the sulfate. And then lastly, we have hydroiodic acid. So if you see the word hydro in a name, that means that there is no oxygen in that formula. So we still start with hydrogen because it's an acid. And then iodic tells me my anion is iodine. So again, +1 and -1, so they just cancel, so it's just HI. This flow chart takes you through all of the different types of naming here. So we're going to do a little practice with determining what type to use. So in NABR, my first element there is a metal. That metal cannot form more than 1 charge, so we just name this sodium bromide. HSO3, my first element is hydrogen, which tells me I have an acid. There is oxygen in this acid, so I follow the rule 8-ic, ite, us. This is sulfite, so this becomes sulfurous acid. Notice when there is an oxyacid, you don't start with the prefix hydro. Cu2O, copper is a metal. It can form more than 1 charge, so you need a Roman numeral. So this is going to be copper 1 oxide. And then lastly, P4O5. Phosphorus is a nonmetal, so when we have 2 nonmetals bonded, we use prefixes. So this would be tetra phosphorus pent oxide. When you are putting formulas together from names, 95% of the time you're going to be writing out the ions with their charges and balancing the charges. The only time you don't do that is if the name has prefixes. So sodium sulfite, sodium is a +1. Sulfite is a polyatomic ion with a -2 charge. So I need 2 sodiums to balance out the charge, so it's Na2SO3. Magnesium carbonate, magnesium is a +2. Carbonate is a -2, so they already cancel out, so I just need 1 of each, MgCO3. Perchloric acid. So there's no hydro in the name, so this tells me it's an oxyacid. It contains oxygen. Ic goes to 8, so this is going to be hydrogen and perchlorate, which is ClO4, -1 charge. So they balance each other out. They cancel each other out already. I just need 1 of each, HClO4. Dinitrogen pentoxide. So when there are prefixes, that's the only time you don't worry about charges. When there are prefixes, you just use the prefix to write the name. So dinitrogen pentoxide. And then lastly, if there's a Roman numeral in the name, that Roman numeral is not necessarily how many of anything there is. It's just the charge of the metal. So all that 3 tells me right now is that the charge of the cobalt is +3. Then we get my anion. Nitrate is a -1. So I will need 3 of the nitrate ion to balance out the charge of the cobalt ion. So it's in parentheses with a 3 on the outside. And